This is the first demo of my new C2 that I've been working on. This is my 3-week progress demo, my first demo, that is, because right now it's in a position where I can showcase how it works. I'm going to be starting up the team server. This is based on a team server and client architecture. I can run the team server anywhere and client on anywhere, but right now I'll be running all of this on my local host. I can log in. There are three types of users. I'll be talking about them in the next part of my video, the next segment. This part is dedicated to showing how it works. Typing help will show you all the commands that you can run. We're going to be starting off running an HTTP listener. You can see you can go to the listener context to do any kinds of listener operations. Listeners would be started on the team server, not on the client. If we type in help again, we see that to start a new listener, this command listener new is used. If I type here HTTP for the type, for my host, and for my port, this starts up a new listener, a new HTTP listener. If we access the address, we'll see that we have a fully functional website running. All the data here, it's all fake, all AI generated, except for the pictures here. The pictures are real. The picture of the author is also AI generated. It's not a real person, it's not a real name, it's not a real biography, and it's obviously not a real news. So if anyone else opens the site, they're going to be seeing a fully functional website. But if an agent communicates to it, it's going to be seeing something more as in tasks. If we switch over to my Windows machine over here, and I'm going to be running the agent, I'm going to be running a debug build because there's a bug I'm trying to fix. This is the bug I'm talking about. There's a heap corruption bug, but ignore it for now. Stuff works even without it. If I continue, the beaconing process starts. If I switch over to my team server and client, right here, we see that a new agent has just checked in. This is the agent ID. It's generated randomly at runtime. We can go back over here, switch to agent context over here and type help, and this will show me all the commands that I can run with an agent. I'll copy the agent ID from here. In case if you missed this notification, you can also run the agents get command to get a list of all the agents. I'll copy the agent ID here and I will run the agent interact command, which will help me access the agent. Once done, I can type help. And these are all the commands that I can run. As of now, there's only the message box because I want to showcase how the agent actually works. In future, agents will be much more featured. So, you know, you can do a whole bunch of stuff with it. Right now, I'm going to be running a simple message box. I'm going to be writing a title, demo title, and the body is I can see you. Hello. Once I task it, the task is created, and the agent, when it beacons again, makes an HTTP request. The team server replies with the command. The command is fetched and it is executed. And you can see here the message box has popped up. Thing is, the executor, that is the thread which executes function, runs on its own very different thread, which means the beginning process will keep on continuing even if the executing thread is stalled. Here, the message box stalls the thread, but if we move on to Wireshark, we can see that the beginning process is still continuing. So this is cool because if there are any sub-agents that are connected to this agent, they can continue to beacon even if the executed thread is blocked. The first part of the video was demonstrating how the whole architecture is up and functioning. The next part of this video, I'm going to be quickly explaining the structure, and you can stop watching now if you came to only watch the demo. If you want to watch the architecture, you can stay here. The architecture is really simple. There's the team server, there is the client, the team server and the client communicate with one another to send commands, get responses, so on. There is also the agent. Agents can be connected to more agents, and I'm going to be drawing a small arrow over here. Every agent maintains two queues for data, incoming data and outgoing data. I'm going to be drawing here two lists over here to showcase that there are two lists. The colors are way too confusing. Hold on. Red. Red for output and blue for input. So where is my paint tool? Okay. This is my output. This is my input. Every agent maintains an input queue and an output queue. Whenever an agent communicates with the team server, it gets tasks, which it then stores in the output queue. I meant to say the input queue. Confusing, right? And there is the executor component in every agent that asynchronously executes everything in here and generates an output which it then stores here. The communicator then sends stuff from the output queue and then sends them back to the agent, the team server. And it keeps on repeating over and over to ensure that execution and communication are two different threads. They don't stall each other. And yeah, that is the how the whole architecture works.